Hi everyone, welcome back to the channel. Today I'll do a video a bit different. I'm going to talk about AI. I'm going to talk about how you can forecast costs in terms of RAG systems, more specifically. I'll explain to you how embeddings work, how vector stores work, how an LLM ingests those embeddings, those vector embeddings. I think it's going to be really interesting to allow you as a enthusiast, or just you if you're a project manager, to forecast prices of an AI system in your company. I'm going to explain to you how the basics work just to get us started, and then I'm going to show you how I made this small free tool you guys can use to forecast some prices. So first off, I just want to talk about some things everyone know. So ChatGPT, as you know, ChatGPT, when you're writing anything to him, what he's going to do, he's going to go search stuff, right? So either he's searching online or in his personal training, it's going to be retrieval of context, right? So the way it's different every time. But one thing you could do is, let's say, send him an image, send him a vocal, send him a video, a link. That's all RAG, right? The whole principle of RAG is basically fetching some context, embedding it, so converting text to a numerical representation, and then when you're querying a document, a web page, any type of document, you're going to basically get a response that is fine-tuned based on the context you provided. So I'm going to give you a few examples of what those could be. So they could be previous chats. So if you had previous chats, the LLM will be able to go query those. You can have multiple things like knowledge base. So a knowledge base could be, for example, in a project I did for a client, they had thousands of documents they needed to be structured and be part of a knowledge base so they can be queried later. So what I did is I basically created a RAG system where I chunked all their documents, and they were able in an intranet to query that knowledge base, which allows their salesperson to find information faster and other employees to use it. So another use case could be other documents. So just you, let's say, inputting an image, asking it to basically identify objects in this image. This will be considered as embeddings also. So all those three use cases all use the same way, right? It's called a vector store. So it's basically imagine it as a OneDrive folder for all your embeddings, your documents, stuff like that. So we're going to talk about what's the cost for this layer. We're also going to talk about what's the cost for this layer, so the LLM layer. This is your models, so it could be Llama, it could be OpenAI, it could be Claude, Anthropic, DeepSeek, whatever you want. And then you got your user. So the user in that case is the one querying that system. So I'm just going to do some few simulations, hopefully to bring you some light on how you can forecast costs and maybe have a better idea of how to design your system. So let's just get started. I'll put the link in the description to this small tool. For this exercise today, we're going to talk about RAG specifically, so retrieval augmented generation. I did put another list, and I'm planning to increase the list of purposes. If you notice, for each label, I also put a small tooltip so you guys can understand basically all this is calculated. So let's just get started with a small use case. So let's start with 1,000 conversations per month. So think about it as, let's say we're to send 1,000 messages to ChatGPT. That would be the equivalent. So 1,000 conversations per month. Then let's choose a model. So in here, I added a bunch of model that basically all came from llmprices.com. So huge shout out to them. So let's go with a model everyone kind of knows. So let's go with GPT 4.5, which is made by OpenAI, one of the most recent models. The first thing you're going to be able to see is different parameters, right? So you're going to be able to see the tokenization settings with a small explanation. Basically, every word is not exactly one token. It depends per model, but usually it's between 0.7 and 0.8 tokens. So that would mean that, sorry, 1.20 or 1.3 tokens per word. So that would mean that it's not a 1-to-1 ratio. So you just got to do the conversion, which I made it here. So what you could do, for example, is let's say in your model, each conversation, so each message you send would be, let's say, 100 words. And then let's not bother about the cached input tokens. This is more of an advanced feature if you guys are knowledgeable with RAG systems or LLMs in general. So I put 100 words, input words. So that could be where is my dog? That would be a query. Let's say there's 8 words. Well, let's put 100 words just to be sure. And then the output words would be basically the LLM answering your question, right? So it would be how many words they're basically outputting to you. And this is usually the most costly part of an LLM, more than input. Usually it's like a 1-to-10 ratio. So just gotta be careful with output words. But let's do a, let's let it at 400 words. I think that's reasonable for now. And then we're going to enter into the second layer, as I talked about. So we're not in the LM space anymore. We're under, so more the embeddings vector store space. And I'm going to talk about different things in the RAG retrieval mindset, right? So first things is when you do RAG retrieval, you don't want to return all your documents to be used, right? Because let's say you have a document about pigs, cats, and dogs, right? But you only want to know how much does a pig eat in a day, right? You don't want to get the documents that are about the dog and the cat. You only want the ones that are in the pig, right? So in that case, you could set a number of chunks you want to receive from all documents combined, right? So let's say there's 500 chunks because you had 3 documents and they had 1,000 words each. So you split them into chunks per document. Now, what it's going to do is when the RAG system queries those chunks and finds the one that is the most relevant, you want to keep X number of chunks, right? So in that case, we could say 5. So usually you don't want to get too much back because all those chunks, they need to be ingested by an LLM, right? So you want to get a number that is reasonable and that's not going to, pump out a whole lot of tokens. So let's just do 5 for now. And then the average chunk size, again, we can do in words. 385 words is kind of big. So let's do the 200 for starters. And then just note that every conversation, you're basically querying context. It's going to add tokens to the conversation, right? So it's going to add context to the conversation, but also it's going to consume tokens in the same way as you would be inputting text manually, right? It's the same context window. So that's an important thing to think about. So we have all that done. So now let's go to the embeddings layer. So the embeddings layer is really going to be the math. So the computation of the conversion to text to numbers. And here I added, different providers. So let's just go with OpenAI for now. There's different models. Like I said, there's basically 3 different models that open lowest amount of dimensions. A dimension is basically just a dimension just in the array of floats that comprises an embedding. So the smaller your embedding model, the smaller dimension, the lower the cost, but also the less the accuracy when you're retrieving. And for large, it's the inverse, right? So the more cost, the more accuracy, but it's heavier to compute and it's more expensive. So let's just go with, text embedding 3 large for now. And you always got the word to token conversion here. And same thing again. So let's just, let's just say you have, 500 documents you want to embed and they're, let's do 100 documents at 1,000 words per document. So that would be 1,000 times 100. So about 100,000 words. And that's per month. Okay, so let's say you have 100 documents per month of 1,000 words to embed. And then you can choose a vector store. So we'll use OpenAI for this one because let's go all in with OpenAI for now. And you'll see basically the costs per month being computed. You can change the currency if you want, but basically per month it would cost you this amount, right? So $171 USD, or $2,000 per year. And you can see the majority of the cost is $144, which is, you know, the model itself. And if we go back to our model, we took a very good model. So GPT 4.5 is pretty expensive also. If we go to a smaller model, you see we reduced by a lot, right? Because the cost is way less for older models. But again, you could play with that and see what suits your needs. Again, you might not need that big of a model. You could use a model that is smaller, right? You could use, let's stay with OpenAI. So we could use GPT 4.1 mini, which brings your cost to almost nothing, right, per month. Again, then your cost will be related to the vector store, right? So depending on how big your documents are, 10 gigs seems a bit overkill. So let's say we do 5 gigs, right? That would be $12 to store your documents, and this scales as you go, right? So if you guys have any ideas of things you'd like to see in that calculator tool, would be my pleasure to do it for you guys. For you guys to use a self-hosted method, right? So we know PG Vector, which is a open source PostgreSQL extension that allows you to store vector embeddings, where you can see the price is like very low because it's not expensive. PostgreSQL, it's not a managed service, so unless you go on a managed platform, then you don't have the OpenAI layer on top of it. And you can also go with, you know, a open source embedding model, which would also reduce your costs. But really, the real cost is not really the embeddings. The generation of the embeddings is pretty cheap. The reason is the storage is really the recurring cost that's gonna really cut your margins if it becomes too big. As you can see, PG Vector is, you know, it's pretty affordable. But if you go in something where you start storing a bunch of images, videos, stuff like that, you're gonna, you know, let's say you reach 100 gigs of storage for that, it's going to cost you almost $300 per month just for storage. And it always scales, you know, linearly, right? Because the more embeddings you have, the more storage you're storing, and the more documents you're querying, well, usually the more you're going to return different chunks, right? Because the more chunks you have, the more potential documents you have matching. So you're going to return them into your input tokens window, which is going to again in turn consume more tokens, right? So it's a linear approach, right? So if you guys have any suggestion on what you like me to add to the tool, just let me know. I'll put the link in the description. And I hope this video could help you understand how LLMs are priced, how a RAG system could be priced, and if it can help you with your specific use case. If you guys have any question, make sure to leave them in the comments, and it will be my pleasure to answer to them. I'll see you guys in the next video.